There we go. Clearly make sure you have the power disconnected. Okay, so heater, pump, and the main in goes to these 3 points here. Ground to the ground bar. White and black called out here, and I actually have like pinned power inputs. So we're gonna take the Spa Pack out today completely. So what I want to show is these temp sensors up here. They are omnidirectional. It doesn't matter which way you plug them in. There's also this top side here. That's the little phone jack. These are the temp sensors. This is a light. This is our heater, which loops back around and touches under here. This is the heater element, or rather the heater body here with the element inside. And then you've got, let's see, these are jumper leads within the pack. We'll need to make sure these are replicated. And then all fuses have to go back into the same spot, as well as any dip switches need to be in the same position on the new pack as they are in the old one. So here we've got 3, 7, and looks like 10 up. That's a 10 segment. Yeah, 3, 7, and 10 are up. So I need to make sure those are up on the other ones. Key way to do this is don't make any changes to the pack until you've got the other one in your hands, ready to go. Don't pull anything out of here until you've got the other one ready to go. So what we're gonna work on is dismounting this right from the board. See if we can pull everything except for, looks like maybe the wires. Maybe this ground right here might need this one right here might need a little pulling out of there. So on the board, I see 1, 2, 3 screws in each corner, plus a 4th that's been covered in like Loctite or something, so you know if it's been taken out. It looks like it's just the 4 screws on the inside, so we'll start by taking the power out here. Now, I always refer back to this. You've got line 1 black going to J26, and line, well, let's call it neutral here, going to J27. This is just a 120 volt system, so it's just off of a plug. Let's start with removing those. All right, so that's our power disconnected, main power right from the board. Let's take the ground out as well. Flat. All right, so now that's all the power, the source of the power, removed from the board. Now we're gonna need to drop that out the way to get the board out, so I'm just gonna hit this ring. Let's see. Couple times until it loosens. Being a bit stubborn. Fisted hammer here. Let's use a real hammer. There we go. Get it loose. Once we got it loose, just drop it right out. And we'll need to spin that ring on after, so don't lose that ring. So they got this terminated in a little push pin connector there. Just draw that power out of there for now. silver screw here somewhere. Oh, yeah, on the inside. Okay. Take all that out. There we go. That sounds promising. Okay. Now at this point, I'm going to unclip the pump, which is 4-wire because it's a 2-speed pump. We're going to unclip the heater, which is 3-wire, including ground. Okay. Internal screw there. Alright. And then we've still got the top side connected and the light. We need to go back in the exact same spot on the new pack, right? So it's not like we have to think too hard about where these go. Remember, the temp sensors are bi-directional, so it doesn't matter if you pull the bottom one out, put it in the top again. There we go, there's the whole pack, completely removed from the spa. Okay, so what I'm going to do is lay these two packs absolutely side by side, and I'm going to try and replicate them. Move the fuses over, move the leads, and then actually move the boards. So let's get our knife out here. Start opening up the new one. We got it brand new from Central Pools and Spas here in Ontario. They're out of Midland. Great people up there. Fast shipping. They do tend to work with suppliers and dealers more than the average person, so if you need a part, come through us here at Rentals, and we'll get it for you. Okay, so before we even unplug or plug anything, we want to visually identify that the two spa packs are in fact the same. So I'm going to move this just into the spot so you can see the two. There's one. Try not to touch too many of the contacts on the board. Touch it as least as possible. I'm doing this, it's quite a warm day, so there's a little bit of water flying around me here. I want to try and make sure no water gets on the board. So I might cover it here and there. And I'm going to use the same wrapper that it came out of to put the board down on, so it doesn't bend any of these pins or nubs at the back here. So you see these nubs, 3-dimensional. Just want to put them down on something soft there, like a wrapper. Okay, so let's get that in a better position there so you can see what's going on. Okay. Alright, so we got the two boards. One's in the enclosure and one is without. So we need to make sure that the one is identical to the other before we even really begin. See, I've got our two fuses. Okay, we'll get a third one here. 0.25 amp. That'll be the board fuse there, protecting the fine electronics. Okay, and we've got same number of pins. Jumpers are currently, oh, there we go. There's one jumper that wasn't in the same spot. We're just going to move, see how this one goes up to the third. I don't know if that's, yeah, you can see there's 3 pins there. This one is currently on number 2 of 3. Now, if they're both common, it probably doesn't matter, but let's just make sure that this is over on that pin there. So, just gonna pull that out. Lift it and put it right back down, one slot over. There we go. So now it's, you see there's 3 tabs and it's at the furthest left one, or furthest right one to you. Okay, so our jumpers are in the same spot. Our two, this one doesn't have too many jumpers. Some of the more complex packs, you have like 10 jumpers. You have to match exactly. Be aware that each of these pins has a like an identifying number. Usually it's a J number, J29, J26. And you can replicate what you see using this. So for instance, we could double check that the black needs to go to J26 there. And I'm reading that upside down, so that was pretty good. So, next, we just want to make sure this is perfectly replicated. So let's work on these dip switches. I see they're in different positions. Use a fine, like a number 0 or a number 1 screwdriver for this, or a toothpick, or something with a nice fine point. I'm going to use a number 0 driver here, something really nice and small. Ignore the rust. Okay. So here we've got 3, 7, and 10 are up. I need to replicate that. So 2 goes down, 3 up, 7's up, and 10's up. Now just to double check what we're turning on here, this is called out right here. So 3, mini panel. Here the number 2, the one we changed, was just how many buttons are on the top side. 7, they've got standard mode only, and 10, low amp, no heat with pump 1 on high. That's important for keeping max amperages underlined. When this thing's only running off of a plug, you don't want 25 amps going through a regular 125 volt, 2-pin receptacle. That'll burn really quick. So make sure the pack's set up, otherwise you'll burn out the new pack just as fast. Okay, moving along here. I think we're ready to physically move these over. What we've done is we've checked the fuses, we've checked any dip switch positions, and the last thing I want to just see if there is a 250 volt jumper. So for instance, here and here, these are jumpers, these little black boxes, and those are each set off of their 2 pins. So they could arc and touch both pins, or in this case they've just been positioned off of the pin, so they don't actually form a complete loop. These are either resets or 250 volt triggers. So in this case, the original pack, if you can see, they're offset. There's only 2 pins here, and this is floating out in free space. See how it just turns like that? It's not connected to any other pins. That being said, the other one is as well. So on the new one, we just want to make sure, copy that exactly right. So we got not set across 2 pins, you could turn it, same there. Okay. All right, I think we're ready to physically move this. So start by carefully undoing the screws in the old board. The moment for error here is if you scratch the new board. If you run this hard screwdriver tip over the board and you cut into that, then the new board won't work, or you risk damaging it. So we'll just perform that now. So 1. You don't want to strip these screws either, because you'll never get your board out. So make sure you're using the right size screwdriver. Here I've got a number 2 fine point, like a slim number 2, fit into these number 2 screws. And they are number 2. Very few things are actually number 1 Phillips in hot tubs. Try not to strip the screws. Okay, and then lastly, you see we've got this covered in this sort of, I don't know, Loctite or whatever that is. Just kind of want to work through it. Push down, work through it, cut it away a little bit. You start to see this orange stuff come up. You start to see the head of the screw reveal itself until you get good purchase. Then put your hard pressure down and turn. Otherwise you'll strip the screw head out. Just keep putting that pressure down. And clean this screw up before you try to put it back in. Obviously, just take a fine knife, carve out that little bit of Loctite with a knife tip. So there's our 4 screws. Okay. Put those up on the inside of the enclosure lid. Again, it's a inside enclosure part, so I try to keep them separate so we're not trying to put oversized screws into undersized holes. All right, so the old enclosure. Wonder what else is remaining here. We got 1, 2, 3, 4 screws out. I don't see any others. Just double check the back here. Okay. Don't see anything else that will hold. Oh, the ground bar here. feel movement, so it's probably this right here. We'll see if we can take this out easily. It may be a bit of a struggle if that copper is hard and cold. Don't break the bonding lugs there, they're done quite tight. Let's get a pair of needle nose out here. See if we can't. We need to pry that away with a flap first, so just that. I think we're gonna cut that and then rewire it with, I have green bonded wire that I can pull from. Yeah, I think we're gonna cut that. Because what happened there was it got fed in from the end and then bent into place, and you can't take it back out without cutting it. So, get our best pair of cutters out here. It's going to take some strength. This is solid copper. There we go. One and two. A bit of orange down in there. It's just from the Loctite and the screw. I'm still missing a screw here. Like there's maybe a screw under that, possibly. Maybe not. It's definitely still screwed in. I'm gonna say it's maybe these two. Yeah, you know what? Let's give it a shot. Pull this up, see what happens. I don't think that's it. Well, maybe it is. Yeah, it definitely was. Okay, there we go. So there's a couple of screws either side of the transformer there. Actually, you know what? I would have clued into that if I looked at the new board. The new board has a space where those screws are, so pop those in right now before I lose them. Okay. So old board, keep it safe just in case your new board doesn't work. You at least want something that was previously working in there. Even if not every function on it is working, you could at least keep the pump going in the winter or something. That cold is your fear. Okay, so we're gonna move to put the new one in the enclosure. I'm gonna put this one safe and out the way. Just put it in. Again, careful for the pins. You can rob the fuses out of this. You can take the little jumpers. So not a bad idea to keep these even if you're never going to use the board again. They've got parts on them. Those jumpers are good, the fuses are good, etc. So these, where are the fuses? Okay. Fuses are cheap, but easier to have than to buy. Easier to pull them out of old boards when you know they were working, even with some life on them. All right, take a break there, and we'll put the new one in. Alright, part 2 here. And we're just about to put this board into this enclosure, and why don't we just go for it, eh? Just make sure there's nothing on the back that's going to get trapped. We're going to be careful not to damage this. I use the term drop, but carefully place. There we go. So we've got her keyed in so that our screws fell in position there. Just make sure there's no water anywhere on the board. So first I'll just put these 2 down. Yep, they're in. They do not need to be tight, I can tell. They are basically just securing that big heavy transformer onto the back of our box here. Okay, let's retrieve those 4 screws, clean out the one with Loctite on it. And physically we're almost done here. Just need to reconnect this stuff. Now we could test it without actually mounting it to the board, like you just plug the stuff in and turn the tub on, make sure you're running before you actually button the thing back up. That is a lesson learned only with experience. So here what I'm doing, I got my internal board screws here. I'm just clearing out the Loctite out of that screw. Just watch your fingers as you're doing this. So there, it's pretty much cleaned out. Make sure there's nothing else that can hang up on the inside here and cause this thing to strip. If in doubt, only put the 3 screws back in, right? If you don't feel like you can get this one back out, don't put it in. I'm going to give it a shot here. Yep, that one's going easy. So, that, and this guy in here. It's a bit of a tough reach. Might be better to put it up into the pack here. Like, go. Again, these do not need to be killed tight. You're gonna bend the board and strip the anti-conduct on the outside. Tighten these too much. There shouldn't be any rattle, and right now even there's no rattle, and I've only put, well, 4 of the 6 required screws in. So, alright, moving along. Let's put these guys in. Right. Finger tight, right? And now, all I've done here is change the board. The power's the same, the heater's the same, the pack's the same. I've kept the fuses are, well, they're new, but they're the same amperage and everything. So the only thing that I have to replicate from the new pack to the old was this hard copper line. All I'm going to do for that is get some similarly gauged stranded copper and use that to go from our ground pin, which is this one, which says ground right on it, out to this bar here. Now what that does is it ties the circuit board to the outside of the pumps, because if you only attach the source ground, then you're only grounding the internal of the pumps in the heater. You're not grounding the outside shell. So if they ever get a short to ground on the frame of the motor, it won't be protected. So let's do that now before we get too much further. Alright, we're back. I went and got some stranded 12 gauge to replace this. I mean, this feels like 14 or 16 gauge solid, but whatever. Went up a size in the stranded to account for the fact that it is stranded. And then I just want to quickly trim this up, twist the ends together, make sure there's no conductors outside the ground. run here. It's very important that you don't have one of these doubling back and hitting power. So twist them together nice and smooth like that. Okay, now we want to make a little zigzag shape here. And get one end in the second ground hole. And the second, oh, see, I got some conductors there. Get that nice and smooth. And into our ground there. Okay, so that's what it should look like after we're done. I'm just gonna get that loosely tied in. I'll tighten it up after. Just want to get all the ends where they need to be right now. It's flat for this. There we go. Just give her a tug, make sure she's not coming out. And then on the other side here, we just want to make sure we got contact with our terminal screw down here. Here, so I'm just gonna do that till I see the little strands flatten out on the end there. You'll see, I'll tip it up in a second, I'll show you. And then you just want to see those little strands there stabbed through. So now we've got a connection from the ground on the power distribution down to the ground on the outside. So now this ties the power inside of a pump and the outside of the pump together. All go back to ground now. So important, if you take something out, you've got to replace it because you're removing the safety feature otherwise. All right, so back to normal, regular scheduled programming. We still got all this stuff to hook up here. We got clips and power and temp sensors and a top side. Well, why don't we just give it a shot with everything just out of the board here? So, you see, it'd probably be easier just to put her loosely in place here, just before we clip everything back in. Let's see, we want to figure out which one of these is the pump, right? Let's go back to our drawing. Here we see it's actually written right here. Pump 1, here's the heater, and the middle one, they call it an ozone power distribution. So we want our 4-wire 2-speed pump to go far over, and we want our heater to be in the only clip that it fits into. And then for now, let's just get our power hooked up here. So we want white falling out W2. Maybe a bit tricky to fit in here, but make sure you're actually hitting the inside metal there and not just getting the pin on in between the plastic and the metal. You'll form a connection, but it won't be very good, and you may even have heat come from it. Okay, so here we've got power and ground hooked up. My plug's unplugged on the other side there. Like I could actually physically see the prongs out behind me, so I don't need to worry about zapping myself early here, but just get this out to there. We're gonna have to take these out, so I'm just putting these in to test. So let's put our top side in. Light we could leave out for now. I mean, it's not necessary to the operation of the tub, and it doesn't matter with these temp sensors, 1 or 2, 2 or 1, doesn't matter. They're gonna read the same. All Spa Pack, new Spa Pack should be like that. Yeah, the heck, we'll throw the light in just in case it causes a short or something. We'll know right away. All right, so I just want to, before we fire things up, just want to double check. So these outside bonds are for continued operation of the tub. They deal with static, so I'm okay with leaving them unhooked just to test until we get this thing permanently installed, in which we'll want these 3 hard copper lines reinstalled there. These ones here. Okay, so where are we at? Well, I think we're ready to give this a shot. So, like I said, you want to double check that you haven't got any conductors hitting, crossing power or shorting in such a way. All your things are plugged in securely. Okay, now first thing that should happen, and I'm gonna have to move some stuff around here at the top, is that the pump should kick on, and then once the temp sensors determine that there's flow, or rather once they test fire the heater and make sure there is flow running through the system, then it'll fire the heater, but it'll test fire and then go off again and then go back on. And really the only way that you can tell if the heater's working is the amperage that the pack is drawing total, right? Because a pump is, you know, 5 to 15 amps, but a heater is 5 to 15 amps as well. So if you've only got 5 amps on the whole system, you know the heater's not on. So right away, let's turn this to, let's go medium amperage setting, 200 amps here. That should pick up anything in single digit amperage pretty good with 1 decimal point. So we'll see 21.2 or 15.8, that kind of thing. So set it to amps. It can go on any of the powered connectors. So I like to go over the black. In a line system, like line neutral, you want either the red or the black. In a 2-wire system, I suppose you could use the white, but yeah, so get that set in such a way that it's safe. Okay, but we still want to be able to read it, so I'm not happy with that. Let's put it around the other way. So just isolating 1 wire here so we can see our max current. Okay, so make sure that nothing's touching anything it's not supposed to. Make sure our temp sensor divots are nice and tight. Okay. All right. So I turned the system on and I didn't get any output on the pump. So right away I started checking fuses, because the most common cause of something just not working is that there's just no power going to it. And sure enough, in one of the new fuses, straight out of the new pack, is just dead on arrival, right like that. So good fuse, when it's got conductivity, makes a beep when you connect 2 of these resistance terminals to it. This is a common setting on the voltmeter here. Anything with that little speaker sound on it will be a continuity test. It's a great way to test fuses there. So put them on either side, no beep. For example, I'm gonna put it on another one here. There we go, we got a beep. So what the heck? So this is why we keep the old pack. You're gonna check its fuse, see if it's good, and just put it in the new pack. Alright, so use needle nose to pull these fuses out, but be careful, especially around the glass ones. Okay, that's the old one out. Okay, let's put that in. Let's just test it actually before we put it in. Yep, got resistance. Or rather, continuity, I should say, not resistance. Okay, let's just test it once it's in, so we know that it'll make the same sound. Yeah, sure, there we go. Okay, so if this one blows the moment that I turn the system on, what's happening is there's something not quite configured correctly about the pack. So if I get 2 fuses blown within a 5-minute stretch each time after I power it up, it's something with how I've set it up. So let's give it a shot. Let's go back to ammeter function. We keep these leads nice and far away from any power conductors. Hook it around there, and then we can actually see the pump come on. The pack comes on. Okay. Let's try that again, shall we? Okay, so it's just going through initialization right now. It's better. Water moving in the tub. 3 amps, so we know that the system isn't pulling a whole bunch right now. And I put it on high and watch it leap up to like 10 amps. 8.83, not bad. It's a pretty small little pump here. Maybe a 3 horsepower, 2.5, something like that, 2 horsepower. It's the only pump in the system, so I'm gonna turn it off again. Now, let's set a temp. And I wanna watch this system Yeah, so it turns the pump on. And it's gonna fire the heater temporarily just to make sure that it's not gonna short out. And then it'll measure the temperature rising on each of the temp sensors, and that'll tell it if it's got flow, good flow, because the heater will not fire if there is no flow going through a system. And nowadays that's measured with temp sensors, not an actual flow sensor. New systems, that is. Balboa, Gecko, all use temp sensors nowadays. Okay, so far so good. Originally this issue was a heater issue, so it's extremely important that we do have it turn on in a moment here. So far we've just got jets on low, and we're waiting for this to leap for a moment as it tests, and then we'll see the heat light flickering, and then after a couple of minutes the heat light should go solid and continue heating, and we'll see, yep, there, so there's our amperage, there's this testing the heater. Okay. And I can see the water flowing through the jets right now, so I know there's not a flow issue. Okay, so we've got 10 amps, you can see that there. Okay, so there it goes off again. It's doing its little test, it's flickering right now. And then in a couple of minutes or so, it should snap on and hold until it hits the temp. Now currently we're at 66 degrees Fahrenheit. Obviously a hot tub wants to be around 100 degrees. So they've got a few hours, especially these little heaters. They take probably a day to get up to temperature. It's just a little, you know, 7 or 8 amp heater here. Not very powerful, not like the 22 amp heaters on a 5.5 kilowatt system. This is 1 kilowatt if I'm not mistaken. So you're just waiting for it to come back online. We'll hear that snap, and then it'll go. We want to stick around for a good 10 to 15 minutes and make sure that the heater is continuing to heat up. So leave this on, and only then, only after you've made sure that all the components are working, do your final wrap up. So for here, I've got to move my power distribution back inside the box. Right now it's outside. And I've got to reconnect these hard bond wires for the outside shell of the motors. But otherwise, we're successful. So I'm just going to continue monitoring for the second round of heater firing, which will be the last round. So don't worry, if your heater turns on and then turns off, that's part of the regular operation of the tub. That's the test cycle. And then eventually here, we should get it to snap back over. Could be a couple of minutes, could be 4. Oh, there we go. Yeah, just in time. So that seemed like it was maybe a 2 or 4 minute cycle, maybe 4 minutes for test. And here we're holding a nice consistent 10.25 amps, 2.6. So that is the 3 amps of the pump on low, as well as the 7 or 8 amps of the heater. Now, if I wanted to restart the cycle and test to make sure that it would do what it needs to, I would put the jets on high, which should kill the heater, because you do not want 2 high draw items on through a single 120 volt system like this, you know, single power plug into an exterior wall socket. You don't want 20 amps going through the system. So you have to program it in such a way to make the pump too high turn off the heater, and it is typically a setting on the dip switches. What remember when we changed 3, 7, and 10? That's what that is. Okay, so it's holding. So what I'm going to do is I'm going to start clearing away my stuff while letting this go. I'm going to leave some of my tools in place because I'll need them to put this back in. But otherwise, we're good to go here. And great lesson in keeping the old Spa Pack, because that had a bad fuse right from the get-go. Side. Green light for reset. If it's red, it's because it's failed. Right.